In this video, I'll be going over the solution to swapping to palindrome from CodeChef February Lunchtime 2020. So let's take a look at the sample cases. So in one operation, we can choose two adjacent elements of the string and swap them. Then we should make sure that neither of the elements have been swapped before. And then we should use the minimum number of operations to change S into a palindrome, or determine that it's impossible. So for the first case, what we can do is we'll swap these two characters, and then that will give us this string over here. And this is a palindrome, and we've used one swap. So that's our answer. Then for this string, we can swap these two elements, and then we'll get this string, which is a palindrome. And then for the last one, the answer is impossible. So the only swap we can really do is this. So if we try this, then you'll get this new string. And then notice that we can't swap these two characters because we already swapped B and A before. So we can't use them in an operation again because of this constraint in the problem statement. So it's impossible to turn this string into a palindrome. Okay, so let's consider when the first and the last characters of the string are the same. So for example, the character A in this case. And in this case, should we swap any of these characters? And it turns out that it's useless to swap any of them. And this is pretty intuitive, but I will prove this at the end of this video. So let's consider when the first and the last characters of the string are different. And then we have two cases. The first case is if we have an A next to the last character. So then what we can do is we'll swap the last two characters into this in order for these two A's to match. The second case is when we have a B next to the first character. So what we can do is we'll swap the first two characters, and then in order to make the two B's match over here. And if none of these two cases are true, then the answer is just impossible. But there's also the case when both cases happen. And if that happens, it turns out that the pair that we choose to swap doesn't matter, because if we swap this one, it becomes BA and AB. If we swap this one, it becomes AB and a BA, and both of them will result in a palindrome. So it doesn't matter which pair we choose to swap. Okay, so let's look at another example here. So at the start, we compare the first and last characters, and we realize that the only way we can make them the same is if we swap the last two characters into this. So now the two A's are equal. And now we'll consider the next two characters here, and then we'll try to make them equal again. And then this blue color means that the characters have been swapped already, so we can't swap them again. So what we'll do now is we'll do the same thing for these two characters, but we need to make sure that we don't swap any two characters like twice, because that's not allowed. So the only pair we can swap is the left pair. And if we swap the left pair, then we can see that it becomes a palindrome. We can't swap the right pair, because if we do that, then we'll swap this character C again, but then we already swapped it, so that's invalid. So after we swap these two characters, we move on to the next two characters, and then we find out that these two characters are already the same, so we can skip, and then we find that these two characters are adjacent, so that means we can end our process, and then we can report the answer to be 2 swaps. And now after I show my code, the exact cases and the details should be much clearer. So here I start with the left index equal to 0 and the right index equal to n-1. So basically the 2 ends of the string. And then each time I match the ends of the string, I increase L by 1, and then I decrease R by 1. So basically I just move the left pointer into the middle, and I also move the right pointer into the middle. And this is shown here, so I add 1 to L and I subtract 1 from R. And then I also have these variables BL and BR, and these basically show whether L and R have been swapped or not. So what I mean by this is, we can look at this example here. So in the first example here, no characters have been swapped yet, so BL and both BR will be equal to 0. Then after we swapped A and C, we move along with L pointing to B and R pointing to C. And here BR is equal to 1 because the C has already been swapped. Then we move on to the next L and R over here. And here BL is equal to 1 because the B over here is swapped, but then BR is equal to 0 because the B over here has not been swapped. And then we'll look at our cases here. So if S of L is equal to S of R, then this means that the characters at L and R are already matched, so we don't need to do anything. And then we should set BL and BR to be 0. And then otherwise, if L plus 1 is equal to R, then that means that L and R are adjacent. And then if we swap them, we still won't have a palindrome. So in this case, the answer is no. And we have our 2 cases left. So the first case is that we try to swap L and L plus 1. So like in this case. So in this case, if the character at L plus 1 is equal to the character at R, so for example, the character here, C, is equal to C over here, then that means, and we also need to make sure that L has not been swapped before, and if these 2 conditions are both true, then we'll swap S of L with S of L plus 1. And then we'll set B of L to 1 and set B of R to 0, because after we swap this, L will be swapped and then R will not be swapped. And then we add 1 to the answer because we just performed the swap. And then we do a similar case for the other end of the array with R and R minus 1. So in this case, find that S of L, which is A, is equal to S of R minus 1, which is also A. So if we swap these 2, then we can make the 2 ends be equal. So we do that, and then after we do that, B of L is equal to 0 and B of R is equal to 1, as shown here. And then we'll add 1 to the answer. And then if both of these cases don't work, then we just output impossible. Okay, so this is basically the program. Now I'll prove observation 1, which shows that if these 2 characters are the same, then we shouldn't swap them. So the first case is, if the second last character is the same as the last character, then swapping these 2 characters doesn't do anything. So since we want the minimum number of swaps, we should not swap them. And the second character is the second case is when the second last character is different. So maybe it's a B. And then after we swap the last pair, we'll get this string over here. Then since A doesn't match with B, that means that we also have to swap these two characters. And then we end up with this string over here. So we find out that the only possible character which can be in place of this question mark is B. So that means the original string starts with AB and ends with BA. But then in this case, if we swap both of them, then if this is a palindrome, then this will also be a palindrome. So it's useless to swap the first and the last pair because it doesn't change the fact that it won't change if S is a palindrome or not. Okay, so if this video was helpful, then be sure to like and subscribe.